All right, so we are in, sorry about that, Unit 5, Day 4. So we're going to talk about more of the second derivative concavity and that point of inflection. Okay? All right. So if I know that f prime is increasing, then I can say that f is concave up. Okay? So if I can say that f prime is decreasing, again, this is f prime, then f is concave down. So if I wanted to talk about points of inflection with the first derivative here, then I would say where f prime goes from increasing to decreasing or decreasing to increasing at whatever values, okay? And that's what gives me a point of inflection on the original. Okay, if I wanted to look at the second derivative for points of inflection, then it's where the second derivative is greater than 0, then f is concave up. If the second derivative is greater than 0, then f prime is increasing. Okay? If the second derivative is less than 0, then f prime is decreasing, and we're concave down. So if I wanted to just talk about the second derivative versus the first derivative, then I could say f double prime goes from positive to negative or negative to positive at those x values. And that also gives me a point of inflection on f. So depending on what we're given, we're going to have to adapt to how we find the points of inflection. This one happens a lot, and I know it's a little bit harder to think about, but we'll a lot of times be given the graph of the first derivative or something, okay? So we want to absolutely know what those are. So let's look at one and let's see both ways that we could do this. Okay, so let's just take the first derivative. Let's do it the first derivative way. 6x squared minus 6x minus 12. So I'm going to factor that. You go factor it. Do not just write what I write. Pause me if you need to. So I've got a graph here. I know that I have -1 and 2. Okay. So where would that be? Right in the middle of these two. For that, we could also say negative b over 2a. So 6 over 2 times 6 is 1/2. Okay, so 1/2 is right where they're going to be, and I know that this is a smiling. Right in the middle there. Okay, so this is the graph of f prime. So I can see that f prime goes decreasing to increasing at this 1/2. Therefore, f of x has a point of inflection at x equals 1/2. Okay, so I know that basically f of x was concave down from -infinity until 1/2 because f prime was decreasing and f was concave up from 1/2 to infinity because f prime was increasing. Okay, let's go look at the second derivative. And I'm going to go ahead and factor and find where this is 0, because now we're looking for positive to negative, not increasing to decreasing. So I can see I have a 0 here at 1/2. I'm going to make a number line just like we did before of that 1/2, but now with f double prime. So f double prime, if I plug in something before like 0, it's going to give me a negative. And after, so any number, it's going to give me a positive, which means f now goes concave down to concave up. So f is concave down from negative infinity to 1/2 because f double prime is negative there. And f is concave up from 1/2 to infinity because f double prime is positive there. So this is a point of inflection at x equals 1/2 because f double prime goes from negative to positive at that 1/2. So two completely different ways, but we still get the exact same answer. Okay, so let's look at this AP example. This is, did I forget to put the year? I did. All right, but now they're giving me the graph of f prime. Sometimes it's f, sometimes it's f prime, sometimes it's f double prime. We've got to pay attention to what this graph is. Okay, so it's on the closed interval from -5 to 5, and they're telling me, oh, they're giving me a point on f, okay? So this is a semicircle, semicircle, line segment, line segment. Okay, so part A says find all the values for which f has a relative max. Okay, so we got to think back. Relative max is where f prime goes from, do you remember? Positive to negative. And so that is at, oops, not t, at x equals, so where do we go? Positive to negative, -3, and positive to negative at 4. Okay, now it wants a point of inflection. So that's where not f double prime, we're not given f double prime, so we need to talk about f prime. We want to know where it goes from increasing to decreasing or decreasing to increasing. So now I'm going to say I went from increasing to decreasing at -4. I went decreasing, decreasing to increasing at -1. Increasing, 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 increasing to decreasing at 2. So those would be where my points of inflection are. Okay, C. Find on the intervals where the graph of f is concave up. So concave up is where f prime is increasing. And I want you to go find those. See if you get what I get. All right. And then D now says, find on the intervals on which f has a positive slope. F has a positive slope when f prime is positive. So that one's a little bit different to think about. And see if you can go find those. Where is f prime just positive now? Remember, positive, negative. So I'm going to see if you get the same as me. Go ahead and check and let me know. Okay, So the next thing I want to talk about is the second derivative test. Way back, remember when we talked about relative extrema? So now we can use the second derivative to actually help me with that as well. Okay, so if I have a critical number, and I know that the graph is concave down, then what does that critical number have to be? A relative max. If I had a critical number and the graph was concave up, then the critical number must be a relative min. And that's all this is telling me here. So if I have this critical number and I plug them in, if I get the second derivative to be greater than 0, then I know I'm concave up. Has to be a relative min. If I get the second derivative to be less than 0, then I know I'm concave down and I have to have a relative max. If I get that second derivative to be 0 or dne, this test says IDK, try something else, go back to the first derivative test, okay? All right, so let's see what we can do here with the second derivative. So I'm going to take my first derivative, and I'm going to get my critical numbers. So remember, critical numbers are from the first derivative. Let's go ahead and factor. Oh, that is a 5 and a 3, Christy Lynn. Let me do this again. I did not look at that very well. Okay. First derivative. Negative 15x to the 4th. Look better? Plus 15x squared. All right. So negative 15. I can take out an x squared. So x squared minus 1. So I want to know my critical numbers. Those would be at 0 and 1. And, sorry, I can factor that more. Negative 1. Remember? All right. So I have my critical numbers. So critical numbers are from your first derivative. But instead of making that number line how we did before, says, hey, go find the second derivative. So my second derivative now is right here. Then it says, go plug those numbers into your second derivative. So when I plug in 0, I get out 0. When I plug in 1, I get out a negative. And when I plug in a negative 1, I get out a positive. So this means second derivative test fails. So if you absolutely want to know, go do the number 9 for the first derivative test. This tells me that I am concave down, which means that x equals 1 is where a relative max is. And this is that I am concave up. So that is where a relative min is. So now go plug those back to find the relative max and the relative min. All right. Now we're going to look at this with implicit differentiation. This is almost always where you're going to need that second derivative test. I normally don't on the ones we just did. I always do the first derivative test, almost always. Unless the second derivative is just super easy. But when we get to implicit, we're really going to have to do the second derivative test because a lot of times we can't just plug in an x value. We don't know the point, okay? So A says, how do we know that 1, -2 is a critical point? Well, a critical point we know is where the first derivative equals 0. So let's go see if that's true. And it is. So we know that it is a critical point because the first derivative equals 0. Then it says, is this a maximum, a minimum, or neither? And see, like, I don't know. Like, if I wanted to set up a number line and I'm like, hey, I have an x value of 1, and I'm going to pick maybe like 0 and 2 before and after, but I can't just plug them in to that first derivative because I need to know a point. Like, this is -2, and I have no idea what those points are. So this guy is out, okay? I have to do the second derivative test here. Have to. So go find that second derivative. Okay, and see if you got what I got. So now, in order to know if that is a relative max or a relative min, we need to plug in our point to the second derivative and see if we get a positive or a negative. And that gives me out 2, which is a positive. So that tells me that we are concave up. So 1, -2 is a relative min by that second derivative test. Okay? All right. The rest of these I would like to try in class or on our own or when we have extra time for this day. There are some really, really good questions on here. You can try some and see how you do, but ask me questions. We will try to get through as much as we can in class on those. Okay?